Okay, welcome to Unit 4, Continuous Probability Distributions. This is the first lesson. We're going to talk about discrete versus continuous variables. So as a warm-up, I just want you to consider this question. What is the probability that a 355 milliliter pop can, it says 355 milliliters, and if we're talking about just the liquid, not, we understand that there will be a little bit of air at the top, but just the liquid, so we set the factory sets the 355 mils to 355. What's the probability that it is actually 355 milliliters? So we need to see if you can come up with a number, just a percentage that you think might be the probability. So if you can just think about that in your head for a second. So if you've thought about that, we actually think of the probability like some people might think that like is 100% or 50%. The correct answer is actually 0%. And we're going to see that today. Learning target is, I know the difference between continuous data sets and discrete ones. I understand why intervals are used to describe continuous data sets and the probability of any certain value of a continuous data set. The big idea in this unit we're going to actually see is the area under a probability distribution curve for a given range tells you the probability that a certain value lies within that range. So what we know so far is we can calculate probabilities for discrete random variables. So we can answer questions like, what is the probability that if we draw 5 cards, we have more than 3 hearts? So we can say, well, it's the probability we have 4 hearts, and we have probability we have 5 hearts. We can add them together. What is the probability that if we flip a coin 5 times, we get between 3 and 5 heads? So you can say 3 heads, 4 heads, 5 heads. It certainly does matter if we're including 3 and 5 as well. We just got to be able to answer that question. Where are we going? So in this unit, we're actually going to talk about calculating probabilities for continuous random variables. So we ask a question like, what is the probability that a baseball pitcher can throw between 90 and 100 miles per hour? What is the probability that a baby is born greater than 10 pounds? Notice that like these questions all require us to know a little bit more about the situation. What kind of things might we need to know about the situation is the question. So if we want to know what's the probability a baseball pitcher can throw between 90 and 100, we need to really know how many baseball pitchers there are. What are they throwing? What's the average that they're throwing? If baby is born greater than 10 pounds, well, what's the average baby? Like, how big can they get? Those kind of things. We need to know a little bit more about the situation. So what's the difference between continuous and discrete? A discrete random variable is something that a variable or set of data that uses numbers that are obtained by counting. That's not just counting numbers. So we typically used to say that like discrete is non-decimals, continuous is decimals. It's not always true. It's just discrete numbers are obtained by counting, and a continuous variable is a variable that's where the numbers are obtained by measuring. So you're actually like measuring variables. So that's really how you tell the difference. A discrete data is counted. A random or a continuous variable is measured. So can you think of some examples of each? Okay. So discrete or continuous. If we record the size of feet of students in our class, the data points can be either continuous or discrete. And we want to explain how that's possible. So if we're talking about size of feet of students in the class, the data points, and this is actually true, the data points can be either continuous or discrete. We need to explain how that's possible. And so if you think about it, if we think about counted versus measured, something that's counted, discrete, would be something like shoe size. So we want to find out the size of feet, we just ask them their shoe size. If we want to do something that's measured, we actually just take out a measurement for their foot. So we actually just take off the shoe and measure the foot. Some tricky examples, which of the following are continuous? So if we have speed, so something like 30 kilometers per hour, 20 kilometers an hour, 70 miles per hour, this is actually a continuous variable. It's continuous because you're measuring how many kilometers have been traveled in the hour. Brightness of light, so it's measured in lumens. We actually make the argument probably more so towards continuous, but this is a conversation to be had. You got to know a little bit more about light to be able to understand this. If a lumen is like a measure that's continuous, like you can have a decimal number of lumens, there's like a continuous range from one lumen to the next, then it's continuous. But we can also think of it as like it's just really the number of lights that are lit up, and that could be a discrete. So this is a conversation to be had. If you want to think of it like as flipping on a switch, you could argue that it's either on or off, so maybe it's continuous or it's discrete. But if you argue that even if you just flip it on, it's going to take this kind of range on, almost like a dimmer, but like a lot quicker than a dimmer, like you actually dimming it. And so you can really make the argument to continuous. So I would say in general, like this brightness of light is continuous. An average on a test is actually discrete. Average on a test, so the mark you've got out of the total is actually two things that are actually obtained by counting. And since even though it's a decimal answer, like 93.33%, it's actually a discrete random variable because both of those numbers are discrete, the numerator and the denominator. So we obtain them by counting, so we're actually got a discrete variable. The other way you know it's discrete is it's exactly that amount. Going back to the pop can, we can't actually have an exact amount, 355. So I want to talk about that one again. How are they represented differently? A probability of discrete random variables such as flipping heads on 3 coins can be represented in a bar graph. So something looking like this. And so where the outcomes of the number of heads, they're definitely separate. We've got one category versus the other. So this is what we call a bar. Continuous probability of continuous random variables is displayed as using a histogram, which is intervals. And so here we're going to look at a histogram between 8 and 9 here. Like there's no gap. We're not looking at right at 8 or right at 9. We're looking at the interval between 8 and 9. That's a continuous variable. So this example is Chris works at a tire store. Chris can change tires from 8 to 12 with all totally likely inside. So like the amount probability we're going to go 8 to 9 is the same as we go 9 to 10, is the same as we're going to go 10 to 11. So note, when all outcomes are equally likely, we refer to this distribution as uniform, just like we referred to it in the last unit as uniform. Except before we did like a bar graph, like 1/6 was the probability of flipping the different coins. That was a uniform distribution. This is also a uniform distribution, but it's in a histogram and it's continuous. So we can still use the same language as uniform. Okay. Things to consider. For the graph, what would be the probability that the time is between 8 and 12? So here, this is actually called a probability density curve because it tells you the probability that you are between two values, or the probability that a certain variable lies between two values. So if we want 8 to 12, we can actually see that the probability is going to be 4 times 0.25, and so that's what the really helpful thing about these density graphs is the area. Just length times width is the probability that we're between 8 and 12. And we can actually see that between 8 and 12 is really just 100%. The probability that we're between 9 and 11, so that's actually half of it. So if we have a length of 2 and a height of 0.25, we get a probability of 50%. Between 8 and 9, it's a length of 1 and a height of 0.25. It's the probability of, and by label the y-axis, just mean to put the 0.25 there. But it's just a probability of 25%. So it's actually, and you can see that it's a quarter the size of the entire box. Another question is exactly 9 minutes. So we go back to the initial problem about the pop can. So what's the probability that he changes a tire in exactly 9 minutes? It's the same question as the probability that a pop can actually contains 355 milliliters. The thing is, this is a continuous variable. So if we have exactly 9 minutes, that actually isn't something that we can calculate. Because, and if you look at it, the histogram, it doesn't actually have an area. It's a width or a height of 0.25, but it doesn't have a length. That's 0. And so if the length is 0 and the height is 0.25, the area is 0. So the probability that you're exactly 9 is 0. Now that's a different question than the probability that you're between 8.9 and 9.1. That would have a probability. But any exact value will not have a probability. And that's the reason why the probability of a pop can being 355 is 0. The probability of pop can being between 354.99 and 355.01, well, that might be a lot higher. But being an exact value, the probability is 0. Some discussion questions to think about. A student in class says that he can tell that data is continuous because the numbers have decimals. Give an example where this is true and where it's not. And so we can think about, like, well, I mean, just think about where discrete values have decimals and where, or continuous variables have decimals and where they don't. And so we can see a continuous variable could be rounded and not have a decimal. A discrete variable could have a decimal, like as a percentage. And so, like, it's not necessarily true just to have decimals. Second one I really liked, digital cameras advertise continuous shooting mode, which state a speed of 5 frames per second. So 5 frames per second is actually how many frames you have in 1 second. And that's actually a discrete variable. It's counting the number of frames that happened in that second. It's probably not a good name. A discrete shooting mode would probably be better. I really like to talk about this because The Hobbit recently was groundbreaking at 60 frames per second. And 60 frames per second was supposed to be this amazing thing that your like brain couldn't even comprehend. It's so fast. But then I started thinking about what would continuous actually mean. Like, how many frames per second do we actually see? And technically, the real world is infinite frames per second. The real world's not broken up into pictures. It's broken up into it's continuous. And so that's what they're trying to recreate. And that's why they call it continuous shooting mode. They're trying to recreate it. Why is discrete data set displayed in a bar graph, continuous data set displayed in a histogram? It's just that idea that you're not looking at 8, 9, 10. You're looking at between 8 and 9, between 9 and 10. There's no gap between the data. Whereas, like, if you roll a die and it's got to be 1 to 6. It can't be 5.5 or it can't be 5.9. So that's why we've got continuous data set in a histogram. Give an example of data set could follow a uniform distribution. You could think about that. We saw one in the example. I think that would be a tough thing to come up with, though. Actually, something that follows in a uniform distribution, because you got to think like everything is equally likely, and that's not always the case. It's just not something that always happens. Was the relationship between area of the rectangles on a histogram and the probabilities? So we saw that, like, the area of the rectangle is the probability, and we're going to see that more in the next lesson as well. And what is the probability that a continuous random variable takes on an exact value? And we talked about that. And it is actually 0. You can't actually be on an exact value. You can be between two values for continuous, but you can't be on an exact value. Okay, so here's the practice questions you can try.